Service Plus sheet metal, where our kitchen counters are being made. Hey, Ed.
Hi, Bob. How are you?
Good. How are you?
Nice to meet you.
How's our job coming along?
It's coming along fine. We'll show you that a little bit later on in the tour.
Okay. Now, is this the basic starting point for all of this sheet metal stuff, all this stainless, the raw material here?
Yeah, basically it all comes in sheet stock. It comes in various sizes. You'll see some tubing product there.
And tubing product for legs and stuff.
Yeah.
How heavy is this?
Well, this gauge here is a 14 gauge, which puts it just a little bit thinner than 1/8 of an inch, and that's what your top is made of.
And so they put the protective vinyl stuff right on the top side.
They do, yeah. That's to protect the shine, the polish that comes in from the factory.
Okay. Now, what is it in stainless steel that makes it perfect for the food industry and that keeps it from rusting?
Well, basically stainless steel is rust-proof, so it won't rust, and it's a hard surface, so it's non-porous, so food juices won't sink into it or anything, and it has good longevity.
And it's mostly a nickel alloy with the steel, right?
Yeah, nickel is one of the main alloys in the stainless steel to make it stainless, make it non-corrosive.
What do you pay for the sheet goods like this, a 4x10 foot sheet?
Well, it's sold per pound, and the poundage price now runs anywhere from $1.10 to $1.20 a pound.
It's a beautiful finish on it.
Yeah.
Where do you start the actual manufacturing process?
Well, what we do is once we take it in sheet stock, we move over to the shear, and we shear it to size.
So is this machine simply a cutting blade?
Yeah, it's what we refer to as a shear.
But is it one long blade, the whole width of the machine there?
Yes, it is. It's 12 feet long.
A 12-foot long piece of steel blade. And they're referring to a plan, a sheet here?
Yeah, what we call these, Bob, we refer to these as breakdowns. This is the engineering from the office. It comes out in here and it determines cut sizes and the layout of the piece.
All right.
They're going to shear this piece here right to size, length, and width. The sheet's got quite a bit of weight to it, so it takes a little bit to line it up to the measurement.
Is this an electrically powered?
Yes, it's electrically powered, but it has a flywheel, so it picks up all its tonnage and inertia from the flywheel spinning.
Wow. How much thickness of steel can it cut?
This thing here is a big shear. It'll cut up to a 1/4 gauge capacity, full length of the blade. So
a 1/4 inch thickness of steel?
That's right, full length of the blade at 12
full length
feet.
of the blade, so it doesn't come down flat, but more like a guillotine kind of.
It does. It comes down at an angle. It comes down, stopping at this end, and will work its way right across.
Great. So once you've cut, wow, once you've cut your sheet metal, your stainless steel, what's the next step?
Well, then what they do, they take it over to the layout area on the bench here, and they put it up to scribe it. Well, this is what we call the layout station, Bob.
All right, so they've just cut a sheet on the big blade over there, and then they're laying out basically all the other cuts and holes and things that have to be done in the fabricating process.
That's right. They take this breakdown, and they're going to scribe that piece with this image, and that'll give them their notching, bending, and hole locations.
So that's it's a complicated thing, because what you're building here is a 3-bay sink, right?
That's correct.
And you've got to precisely locate all the bends, all the cuts, all the holes, and everything else that goes in there.
Well, this is where it all starts. It has to be accurate over here because we're held between measurements when the product is finished, and it all starts over here, so we've got to be very accurate over here.
Okay, then what happens at this station over here?
Well, what we do over here is we punch various shapes in round holes. This one here is a faucet location.
So this is pneumatic?
It's a flywheel operation again.
Again, it's a flywheel. You got a lot of force there.
Oh yeah, a lot of resistance through stainless. It's tough to punch through stainless.
There we go, 2 faucet holes. Okay, and then what about back here?
Well, now, what we do over in this operation is called the plasma cutting.
All right, so this is how you go about making square cuts or round cuts in the interior of the sheet.
Exactly, because we have no way of working our way in from the edge. So this will make a cut right in the middle, and that's a sink cavity he's cutting out. We'll weld the sink right in there. He's cutting the corners first.
And he's just using a little stamped out circle.
Yep, just as a jig. He'll do all the corners first, and he'll tie them together.
So the plasma cutter basically is superheating it and melting right through the stainless steel.
Exactly, and then we have compressed air in the bottle that blows that slag away at the point of it melting.
I see.
Makes a nice, neat cut.
So that's an interior cut. We've seen holes punched. We've seen perimeter cuts. What about when you bend the stuff?
Well, that happens over here, Bob, at this machine called the power brake.
All right. Now this is a pretty impressive brake.
Yes.
And what are we doing with it? What's the?
They're putting a roll in that. It's a two-step process. Now that's around 90 degrees. They'll hit it a second time. It'll come around 180 degrees.
So that's how you make the kind of the bullnose or circular edges.
Yeah, that's what we call it, is a bullnose edge. It's about half a circle, basically.
Yeah. Oh yeah. So he can control how much pressure he puts on.
Yes, he does, with the foot pedal over there.
With the foot pedal, right. Now, how do you rate these instruments, these brakes? I mean, I'm used to seeing the kind roofers carry around in their truck, but this is a pretty heavy affair.
Well, this thing here is a 65-ton brake. That means it's capable of exerting 65 tons of pressure. It's a pretty powerful brake, but they do make them bigger.
Boy, not bad. Well, I'm really curious to see our order. Where do you have that?
Well, that's over this way here now, Bob.
Oh boy, now look at this. This is upside down, but this is basically our unit, and we can see what we just learned about how you roll the edge and how you bend it on the brake. And
yeah.
Now what about this?
Well, what we've done, we showed you the tubing product earlier. This one here is a leg 1 5/8, and it's welded to a galvanized channel for structural and support. And here's your undershells. It's all welded construction.
Now, why is this galvanized?
Well, it's a cost saver because
it's
underneath and you don't see it, so why waste the stainless steel?
Right. And did you say this was our field weld?
Yes. If you move right over here, underneath this channel, we have the seam that this table will come apart in 2 pieces, and then we'll field weld it on the job site.
Okay, because you have to transport it in 2 pieces,
That's
obviously.
correct.
Okay. Well, I can't wait to see it installed. Ed, thanks for the tour.
You're very welcome.